So now in this video, we're going to be looking at changing voltages. So these principles apply in a whole bunch of circuits, if not most advanced circuits. So in any case, we have, let's go over the layout, a 10 kilo ohm trim pot right there, and then two 10 kilo ohm resistors right there forming a voltage divider. We have 18 volts at the rail. I have this oscilloscope here, and the cable there has alligator clips, and I have alligator clips that I crimped onto jumper wires. So I just connected them together so I can quickly move the contact points that I'm going to make. So first, we're going to go to the trim pot itself, right there. So it is a voltage divider. It is set halfway. So it's a 10 kilo ohm resistor, and so right now about 5,000 ohms towards the positive rail and about 5,000 ohms towards the negative rail. The main takeaway though is it's a voltage divider. The exact resistance does not matter, except for we're dealing with about 18, or actually about 19 volts right there. We're going to go there. This is 5 volts per division right here. So you can see that here's our 0 volt reference point. I could move it down there, but I have it up there. And we got 5, 10, 15, almost 20 volts right there. And I have my bench power supply set to 18.5, but it's not 100% accurate. So it's somewhere about 18.6 volts. Now, we also have this jumper wire going to the middle terminal. So there's a middle terminal there, and there's just 3 wires. I like this trim pot a lot. 3 wires right there. Kind of wiggles though a bit. So it's not solidly in the board, but in any case, it's pretty nice. I like these. So I like these blue ones with the 3 wires. And it has a jumper going to the LEDs. Let's look at the LEDs. So they are really polarity indicators from this point to that point. Actually, from this point all the way to that point. So the red LED, you can see the long lead, the anode is up 1 row, short lead, the cathode, is down 1 row, right next to the yellow one. And so the yellow one's in the same 2 rows, except the longer lead, the anode, is down 1, and then the short lead, the cathode, is up 1. So they're in opposite directions. Each one of them will conduct one way but not the other, and it's opposite ways. So there's 2 10 kilo ohm fixed resistors right there to make sure we always have resistance between the rails. So if I turn this all the way up to the positive rail, we have positive rail coming to the LEDs, and then we have resistance to the negative rail. If I turn this all the way to the negative rail, we have a direct connection from the negative rail to that LED, and then resistance to the positive rail. Now let's get back to taking a measurement. So there you can see we have right now the trim pot turned to the negative rail, and as soon as I turn the trim pot, we get a voltage change. You can see the voltage changing at the trim pot right when I turn the dial right there. And then the halfway point again, we have the halfway point right there. But now let's do a little more interesting. So right now we have half the voltage there, and we're going to go over to where the LEDs and the 2 resistors, the voltage divider, connect. There you can see we have half the voltage of the power supply voltage, and that's what we expect because they are equal value. One goes to positive, one goes to negative. But you'll notice here that it's pretty easy to drop it to almost 0 volts. So not quite 0 volts because the LED has some voltage drop, and about 1.5 volts or more, maybe 2. And so there is not quite 0 volts, but pretty close. That's because we are to the negative rail there. It pulled the voltage down, even though we have 2 fixed resistors right there. So now let's turn it up to the positive rail. We'll see the opposite. So we have almost the 20 volts, but minus. First off, it was closer to 19, probably a little less than 19, and then we lost a couple more volts. So this is probably about 17 or so, something like that, 16 actually. Now 5, 10, 15, a little bit more. So we're not getting quite the rail voltage. We can just pop this out quick and go to the rail, and see how much higher it is. So it's a couple volts higher. Now, so we got that. We have a direct voltage change right there. So hopefully that all makes sense. Now we are going to move on to the capacitor, because capacitors, unless there's no resistance at all, capacitors take time for their voltage to change. So now we have a 10 kilo ohm trim pot put all the way to the negative rail though. That jumper goes from the output there to a 10 kilo ohm resistor to the two LEDs, again wired as polarity indicators. One is one way, the other is the other way, and then we have a capacitor. So we got the negative side to the negative rail. This is a 1000 microfarad capacitor, which is about the largest normal size capacitor that generally people have. There are larger, there's also super capacitors, but for the most part this is a fairly large value for regular capacitors. Now we have the trim pot set to the negative rail. Let's get a voltage of where the LEDs and the capacitor connect. So you see it went up a little bit, so it's not going to go to the negative rail, and this does not want to go on the board. There we go. So finally it went in the board. There we can see the voltage there. Now I'm going to rapidly raise the voltage there, and you don't see the sudden voltage change at the capacitor. There was a sudden voltage change at the trim pot, but the capacitor takes time. So you saw the LED light up, and it was relatively bright. In fact, let's swap out these two LEDs for a green one and a blue one. So now I got a green and a blue LED ready. We will pluck these out. They are just naturally brighter. They're a whole lot brighter even when you have the exact same amount of current going through them. In fact, they're brighter with a lot less current going through them. So it doesn't matter which way we put them. I'm going to put the long lead, the anode, of the blue one up, short lead, the cathode, down right there, and we're going to take the green LED, do the opposite. Short lead, or the long lead I mean, the anode's going to go to the capacitor. Short lead, the cathode, is going to go up one row to this resistor right there. Now we're going to zoom back. We're still measuring the voltage of the capacitor. We are up all the way to the rail, and I'm going to quickly, looks like the blue LED is lit a little bit. I'm going to quickly go down. You see the green LED lights up, and that's a whole lot brighter. Now there is a voltage difference across the resistor. We got the negative rail voltage, plus we have that voltage at the capacitor. So that voltage difference minus the 2 volt drop of the LED, actually 3 volts. These block more voltage than the other two that we had. The blue and the green block about 3 volts, whereas the red and the yellow block about 2 volts. But you can see as the voltage gets closer to 0 volts, actually about 3 volts, and the rail is 0 volts, then there's practically no current flow. And the current is also set by our 10 kilo ohm resistor. So now we're going to quickly turn this up to the positive rail. You don't see the rapid voltage change, you see a slow voltage change of the capacitor. And as the capacitor voltage gets closer to the rail voltage, then the less current flows, the less light that the blue LED produces, and also the capacitor starts charging slower. So that's how voltage changes with a capacitor. And now moving along, we saw how long it takes for the voltage to change with a 1000. You can see that a little current's going through the LED. Not much voltage change, also it is hardly any current. But in any case, there is still current going through it. When I pop this out, now current's going through the meter. So actually that was the current going through the meter. That's another interesting thing. So in any case, we're going to pop out the 1000 microfarad, and we are going to put in a 100 microfarad capacitor, because that will mean that first let's make sure it's discharged. We're just going to put both wires to the negative rail. That will discharge it, so there's 0 volt difference across them. So now we need to make sure only this side goes to the negative rail. We're going to put the long lead to the LEDs right there, and now you can see how fast the voltage changed. So it wasn't instant. like when we had no capacitor, but it is quite a bit faster, as you can see there. So I'll go down there. So now you see the RC time constant curve right there. So it takes one time constant to charge about 2/3 of the way, approximately. And so that depends on the resistor used and the capacitor that was used. So you can see we get about 2/3 of the way pretty rapidly, and then it takes about the same amount of time to go another 2/3, but that 2/3 is a whole lot smaller. So it just kind of curves like that. That's an RC time constant curve. So one of the ways to affect that is to change the capacitor. So this one's really fast. Even with 10 kiloohms, it's relatively fast. Let's make sure this is discharged, and we got a pop because there was 18 volts across there. And so now we pop it in there, and we discharge it, so it's nothing. Let's go up, and you can see how slow it is. So that is with the 10 kiloohm resistor. And now I have a 1 kiloohm resistor. So let's turn this down and look at the curve really quick. And you can see, of course, it's really slow. And I'm going to pop out the resistor, and voltage should pretty much level off. And now we got the 1 kiloohm resistor instead of a 10 kiloohm resistor. And so we'll probably see about the same curve. You can see the LED got brighter too, because there's a lot more voltage involved. But they're maybe even a little more than recommended for these LEDs. So I may be abusing them a little bit right now. I'll have to do the math on them. We're dealing with 18 volts and a 1 kiloohm resistor. So I think we're kind of at the limits of the current that we should put across the LEDs. We're exceeding the wattage rating of the resistor, but right now we have 0 volts at the trimpot, almost 0 volts at the capacitor. There's not much voltage difference. So there's almost 18 volts minus the LED drops though. So actually maybe we're dealing with like 14. But in any case, there is a higher voltage difference across the resistor when the LEDs are brighter. That's also when the voltage change of the capacitor changes the most, as you can see right there. So we can either use the resistor or the capacitor or both to set the timing. So we're still at the higher value resistor, but now a lower value, or the higher value capacitor, but we have a lower value resistor. So if we use a 1000 microfarad and a 1 kiloohm resistor for a certain time, we could swap that for a 100 microfarad capacitor with also a 10 kiloohm resistor. So we will get the same time. We balance out the capacitance and the resistance.